Welcome back to Lamarville Projects. Today we're going to explore everything electrical and our control box and everything in between. Today we're embarking on an electrical journey, exploring the intricate workings of all the electrical systems and our control box. Crafted with precision and purpose, at least the best I can do, this control box is the backbone of Lamarville's electrical system. And now the centerpiece of our operations, our electrical control box.
Let's delve into the details. From its dimensions to its construction materials, every aspect of this box has been carefully considered to optimize functionality and efficiency. At the time, I didn't have FreeCAD or SketchUp, so this is my version of a detailed diagram showcasing the dimensions and construction of the electrical control box. Now let's take a closer look inside. The box measures 24 inches wide by 34.5 inches tall and 15 inches deep, made of mostly 3/4 inch maple plywood and a few other materials. All the pieces are screwed and glued together. The box was built to be the central part of the railroom main electrical center. The goal was to provide all power to all the layout's needs for the locomotives, the tortoise switching motors, bridge linear actuator, scenery lighting, and any other electrical demand I could think of. Because of my limited space in my 11 by 12 foot room, this flip-out design minimizes the footprint while maximizing functionality, and when it's not in use, we just simply tuck it away. The flip-out switchboard was designed to provide seamless control over our model railroad. With 15 switches controlling 19 turnouts, 3 track power switches, and 1 program track main switch, enabling me the opportunity to program locomotive decoders on the layout. All these switches are single pole double throw. The flip top presented a challenge. I'm not a skilled woodworker by any stretch of the imagination, and there was some weird angle to contend with. I had to figure out what would be the best angle and some close measurements so when flipping out the board it would not hit the benchwork or bind with anything else. I simply used a piano hinge and a strap for my soft stop. The panel was cut from a piece of masonite. The track layout design was done on any rail, printed up through staples because my printer would not print anything larger than an 8.5 by 11 piece of paper, and I sandwiched it with a piece of plexiglass. Now I'm all set up to start assembling my switches. Now you'll notice double throw double pull switches, but later I changed them to single pull double throw switches, which I unfortunately did not take any pictures of. When I did all this, I never imagined I'd be making a YouTube video depicting the build. I didn't need the double pull for my turnout switches since I was using an NCE button board. If I would have been controlling the turnout's motors directly with the switches, a double pull switch would have been required. Here's a demonstration of one of my turnout switches being activated. It's a little difficult to see the turnouts from the angle I shot it, but the arrow shows where they are. I'm activating my Lamarville South Yard mainline switch 1, which turns 2 turnouts with 1 switch. The NCE switch 8 MK2 is rated at 40 milliamps per channel. Each tortoise pulls anywhere from 10 to 20 milliamps depending on the track voltage or the DC power supply you have. I'm running a dedicated 12 volt DC, so my amp drawer to each channel with 2 tortoises machines are pulling about 30 milliamps tops. Now let's move to the second drawer. This section houses many of the electrical components necessary for operations. The front panel has 2 power buttons for main track power and auxiliary power. Each power bank has a dedicated voltage and amp meter, as well as the standby power on LED indicators. Inside the drawer is my NCE Smart Booster SB5 for my power cap, along with 2 NCE Switch 8 MK2s with 2 NCE button boards, which we briefly spoke about earlier. I used an old ATX computer power supply unit and repurposed it by cutting off the factory installed leads and simply utilizing the power cables. As shown in the diagram, yellow is your 12 volts, orange is your 3 volts, red is your 5 volts. Black is a negative to all of your voltages. Purple is my standby cable wired to a 220 ohm resistor and LED. The green wire is my main power on cable, also wired in series along with a 220 ohm resistor. All these components are arranged and connected for practicality and functionality. The utilization of terminal blocks throughout the cabinet provided me flexibility should I expand or the need to adjust something. I had to wire the flip-top board switches to my NC button board, then run wiring from the NC button boards to the NC switch 8, and then out to the tortoises. To keep track, no pun intended, of everything, I had to create several wiring diagrams to keep records of what components got connected to what terminal block and so on. My wiring diagrams were pretty crude, and it took me some trial and error to get it right. The bottom drawer is where I keep all my essential electrical supplies and documentations close in hand, so there's not much to see there. Now let's shift our focus to the layout itself. Lamarville has 19 tortoise slow motion switching machines throughout. Normally you solder the wires directly onto the tortoises, but I went another route. I purchased 19 of the AccuLite 100 tortoise card edge connectors, so if a tortoise goes out, it makes it easy to replace it. At least that was my thought process at the time. With all the conductors pre-wired, when it comes time to install the turnout signals, it will be easier to wire them in. My main track power has 4 distribution terminal blocks, all equipped with circuit breakers to protect from shorts. One is with an old-fashioned 12-volt light bulb, and 3 are protected with the NCE225 single output electronic circuit breakers. I will eventually change out the light bulb one of these days. Now, the Lamarville wouldn't be much without any tracks for the trains to run on, so let's talk tracks and the electrical power necessary to operate the locomotives. After I had successfully identified where all the tracks were going to be and where all the turnouts were located, it was time to look at the main bus wires and the feeders for each of the segments. As I mentioned, I have 4 sections that are electrically isolated for several reasons. One is so I can protect each section via circuit breaker. Second, each section has its own bus wire from the electrical control cabinet. Third, eventually I will be placing block detectors to run track signals. My main bus wires consist of 14 gauge multi-strand copper wire. I chose the 14 gauge for my buses so it could carry the loads not just for the tracks, but for any other DCC accessory I may eventually add in the future. I color-coded the mains and the feeders red and black to distinguish, as DCC and DC layouts are polarity sensitive. I also made sure that for the entire layout, the reds color conductors were near and the black color conductors were away. That ensured no confusion as I wired the layout. For my feeders, I used 18 gauge single strand copper wire. I decided on single strand as it would be easier to solder the ends to the tracks rails. It took a bit of finessing soldering wires to the rails, as you want to get the rails hot enough so the solder and the wires bond together securely without melting any of the plastic ties. Connecting the end of the feeders to the bus mains, I used suitcase connectors. I read and seen many model railroad YouTubers that these connectors are no good and they do not recommend them. But in my experience, if used correctly, they do provide a good solid mechanical connection. For my Lamarville West yard, I isolated all of the tracks so I could turn them off individually should I have locals parked in the yard. I didn't need them to run if I didn't need to. The ATX power supply also supplies the necessary voltages for the scenery lighting. Several LEDs are wired into my 12-volt DC circuit with resistors connected in series. Other LEDs are connected to my 3-volt DC circuit. These don't require any resistors connected in series. I connected the house LEDs to an Arduino and programmed it to turn on and off at certain times and in random order. I got the idea and all the necessary information to properly connect and program the Arduinos from DIY and Digital Railroad. See the link in the description. The street lights and yard lights are wired directly into the auxiliary bus feed from the ATX power supply unit, controlled with toggle switches so I could turn them on and off as needed. I have one grade crossing which runs off an Arduino and utilizes infrared sensors to detect the locomotives as they approach, and then they deactivate the crossing lights when the rail cars depart the area. However, it seems there is a glitch. The infrared sensors keep picking up some errant noise, tripping the sensors. When I connect the Arduino to my laptop via the USB cable, the noise goes away. However, even when connected to a separate power supply, example a 12-volt wall transformer, the noise continues. If anyone has a similar issue and found a solution, please let me know in the comments. In future videos, I'll be wiring the New York City section building and streetlights in a similar fashion. Eventually, I also have plans to install 2 working traffic signals in a future video. Well, it wouldn't be Lamarville projects without a little innovation with the use of Arduinos to control certain aspects of our scenery lighting. Thanks again to DIY and Digital Railroad for your excellent video and information. Stay tuned as we explore some cutting-edge techniques for enhancing your model railroad's electrical systems. So there you have it, folks, a comprehensive tour of our electrical and control cabinet where science meets craftsmanship in the world of model railroading. Join us next time when we tackle another exciting project here in Lamarville Projects. Thanks for tuning in today. Don't forget to like and subscribe and hit the notification bell to stay up to date with all the latest adventures. Until next time, happy railroading.